Okay, today's lesson, this is a new topic or new idea. So we're going to do rotation of axes. What is going on here? Okay, so far in conics, we have studied all equations which are some form of this form of equation. So I'm going to write it down. It's ax squared plus cy squared plus dx plus ey plus f equals 0. And here a, c, d, e, and f are all these are all any real numbers. Okay. Now we know that if a and c are both 0, so if these two disappear, then we just have dx plus ey plus f, which we know that is an equation of a line. On the other hand, if only either a or c is 0, so if the a is 0, so the x square is killed off, so then we just have the y square term with the other guys, so then we have a parabola, right? And if both are there, but a equals c and neither equals 0, then we have a circle. And then we have the case if a does not equal c, but they are both same sign. That means either both positive or both negative, then we have a ellipse. And finally, if a does not equal c and a and c are opposite signs, then we have a hyperbola. Okay, now here is the key. All of these, this entire equation always, we can always use completing the square, right? Except when it's just a line, right? But we can use completing the square and get it into the standard form. You can always do this. Now, what's the standard form? Is any of the cases. If it's a circle, it's this, right? If it's an ellipse, it's you get the idea. It's right, and the other form, and then we have the hyperbola. I will put a minus. Okay, so we can complete the square and put the equation into a standard form. Okay, another thing with all of these forms, when we sketch it in this form, if you look at the graphs, whether it's the parabola like this or facing up, whether it's the ellipse sideways or up down, if it's the hyperbola sideways or up down, in all cases, right? In all of the cases, the axes of symmetry, that's here is the axis of symmetry, here is an axis of symmetry. These are the two axes of symmetry. Here again, axes of symmetry, axes of symmetry, axes of symmetry. All the axes of symmetry are vertical and or horizontal. Okay. Okay. All right. So now let's fill in the full form of this equation. Okay. We can see it. We have A, C, D, E, F. There's a letter missing. So the full form would be ax squared plus bxy plus cy squared plus dx plus ey plus equals 0. Okay, now this term, if b is not 0, gives us not problems. It's all it does is then it makes it's impossible. If there is an xy term, it is impossible to convert this equation by completing the square into a standard form, right? It's just impossible because this is not going to go away, this xy term. Um, and we and you can, as you can see, in none of the standard forms and none of these forms is there an xy term. Okay, so there is, I'm not sure, I didn't look it up, but who came up with this insane idea that what if we we have the axes, right? X and Y. Okay. Let's rotate the axes, and we're going to just do, you can do it in either direction, but we're going to rotate the axes counterclockwise some angle, and I'm going to call this angle phi. Okay, I think it's pronounced phi. Not theta, we'll use theta elsewhere. If I turn this in an with a certain angle, so let's turn the axis. So let's say I turned it, and so now this is the new, I'm going to call this is my new x, and with a little dash up top, and we read this, I can read this as x prime. Okay, so there's x prime and y prime. These are my new axes. Okay, and see, I've rotated x and y by an angle of phi, and we have this new axis. Okay, and um, when we do this, we can actually, if we rotate it by the correct angle, we can kill off this b term. Okay, so let's sort of unpack all of this and see what's going on. Um, all right, so let's first see this notion of rotating the axis. So here is the axes, x and y, and here there's a point. This point has an address, x comma y. Okay, all right. Now let's rotate this axis by a certain degree phi. Okay, so this is right angle enough. Okay, and let's label this axis, as I said before, x prime and y prime. So this is x and y. Okay, now, oh, I didn't want to do that. In this new x prime, y prime land, that same point, the point is not going anywhere. I can have a new address for it, x prime comma y prime. Okay, now let's label this point also using our good old, really useful polar coordinates. So one thing won't change. From the origin, I go the distance to the point, that is my r. Okay, and theta, so I'm looking first at x prime, y prime. This is, theta is the angle. Remember, it's the angle from the positive x-axis or the polar axis uh, to the ray which contains the distance from O to P. Okay, or the length from OP, the line segment OP. Okay, so this guy has coordinates also. We can say in x prime, y prime line, this coordinates are r comma theta, right? Okay. Now here we rotated this guy. Let me do this with a different color. We have rotated this axis by an angle phi, So now what would be, so this would be, if I were to locate this point now, this is still R, and so write it in polar coordinate. This is R, distance from the origin to the point, the xy. But what's the angle? Now the angle, I'm looking at it from the, my polar axis is now the x-axis, right? Not that new x prime axis. And the angle, therefore, is this guy, which is theta plus prime. So this is, or phi plus theta. Theta plus phi is the angle, right? Okay. And we know if I drop this line here, then this piece is r cosine theta, and this r, the length here is r sine theta. And if I drop it instead to the x-axis, now we have this length here is r cosine theta, r cosine of theta plus p, and the y is r sine theta plus r sine of theta plus p. Let's write this down. This we know from our knowledge of polar coordinates. So x is r cosine theta, and the y is r, sorry, we had our x prime, right? X prime was, this length is r cosine theta, and the y prime is r sine theta. Okay, and our x is r cosine of theta plus pi, theta plus phi, and the y is r sine of theta plus phi. Okay, so this is my r cosine of theta plus phi, and this piece is r sine of theta plus phi. Let's expand this this one out using our sine addition and cosine addition formulas, and we'll get r cosine theta cosine phi minus r sine theta sine of phi. And y will turn out to be r sine theta sine of phi plus r, my mind wandered, sorry. So I'm using the x is r cosine theta cosine phi minus r sine theta sine phi. That's the cosine addition formula. I wrote the sine addition formula incorrectly. It's r sine theta cosine phi plus r cosine theta sine phi. Okay. All right. Okay. So now let's do this. Okay, now let's just replace. We know our cosine theta was x prime, our sine theta is y prime, our sine theta is y prime, our cosine theta is x prime. And we have our first set of equations. So x is x prime cosine phi minus y prime sine of phi, and y equals y prime cosine phi plus x prime sine phi. Okay, so that means, suppose if you know that I've taken an x and y axis and rotated by some angle, whatever angle I want, say phi, correct? I have a new x prime, y prime, and this is my old x and y, right? If I want to convert the coordinates from x prime, y prime land back to xy land, right? So I want to say this point, I know what is the coordinates in x prime, y prime. I want to change it into X and Y. This is the uh, this is the procedure. So X is X prime cosine phi minus Y prime sine phi, and Y is Y prime cosine phi plus X prime sine phi. Okay. Seems it's you have to remember this at least for a short time, but it's not too bad to try to write. It took me a little bit. I was practicing how to try to sort of remember this. Is um, you know you see that this is cosine sine cosine sine. So the cosine and sine didn't change, but the x and y interchanged between x and y. Okay, that makes any sense. All right, but this is one set. Now we're going to just do a little bit of trickery and get the other form. That is, if I know x and y and I want to find x prime, y prime. So here, if I know, this was when I know x prime, y prime, and I want to know x, y. Now we're going to go the other direction. I want to see if I know x and y, how can I find x prime, y prime? So let's do the trick here. I'm going to multiply the first equation here with the negative sine phi. So this will become negative x prime sine phi cosine phi plus y prime sine square phi, right? So multiplying it by negative sine phi. And the second equation I'm going to multiply just by cosine phi. So this becomes y prime cosine square phi plus x prime sine phi cosine. I add the two equations, right? And I get negative x sine phi plus y cosine phi equals, these two cancel out. Here I can factor out y prime. Inside is sine square phi plus cosine square phi, which is 1. So this is y prime. Okay. Similarly, if I now do the same, again, take the same two equations again. Let's take the same two again. And this time, I'm going to multiply the top by, um, let's see, in this case, we killed off the, okay, so now I'm going to multiply by the top by cosine phi and the bottom by sine phi. So let's see what we get. We get x times cosine phi equals x prime cosine square phi minus y prime sine phi cosine phi, just distributing this, right, to each of these. And the other one will be y sine phi equals y prime sine phi cosine phi plus x prime sine square phi. Okay. You add the two again, and we get x cosine phi plus y sine phi equals, now these two cancel out, and we can factor out an x prime. Inside is left cosine square phi plus sine square phi, which is 1, so x prime. So we have the second equation, that is x prime is x cosine phi plus y sine phi, and y prime is negative y cosine phi. Nope, sorry. It is negative x sine phi plus plus y cosine. Okay. So these are the two equations. Now this one is if I know x and a point in x and y, and I want to see what is that point with the address of p, yeah, with the address p x prime y prime, I will use this equation. X prime is x times cosine phi plus y sine phi. And again, phi is the angle by which I rotate the axes, right? So whatever the angle I rotated the axis by is by phi. Okay. All right. Okay. Now, so well, so far is so good. And let's see. Okay. Now let's. I don't know if I want to. Okay. Let's see. We'll show the. Let's see how far this goes. All right. So here we have ax squared. So now for our main idea, so ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. So this is an equation, and this is in x and y land, right? X, y land. Okay. We want to move this whole thing into x prime, y prime land. And we want to do so by rotating axis by phi. Okay. Now, think about it. We want to rotate the axis in a way, now bear with me, somehow so that this xy term disappears. Like just magically disappear. My spelling of disappears is disappears. I think it's two S's. Yeah. Anyway, so by rotating the angle axis by phi, by a phi which we can calculate so that the b term becomes the xy term disappears. That means b will be 0. That means, okay, this b term will become 0. So let's see how are we going to do this. We are going to go into x prime, y prime land. So we are going to replace, let's replace all our x squares. So all our x's here with, remember x is x prime cosine phi minus y prime sine phi, right? X is x prime cosine phi minus y prime sine phi. It's getting squared plus the b. We are going to replace the x with x prime cosine phi minus y prime sine phi. And the y part, the y term will be, remember the formula for the y prime is, so y is equal to x prime y is x prime, y, what was y is, what was the y? I'm trying to just make sure I remember it myself. So the x was x prime cosine phi minus y prime sine phi, and the y will be is 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 y prime sine phi plus x prime cosine, and the y is x was this. I don't want to look up there. It's right there. I'm just forcing myself to remember. It says that the x was this, and the x is this, and the y prime, the y is, it's not this, it's, sorry, the y is y prime cosine phi plus x prime sine. I think let's look up. So y is y prime cosine phi plus x prime sine phi. Yep. Okay, sorry about that. Now plus c, this is a little bit plus c. Now I'm going to replace the y square with y square. So y is again, y is y prime cosine phi plus x prime sine phi squared plus dx. And here again, the x is going to be x prime cosine phi minus y prime sine of phi plus the e. And the y will be y prime cosine phi plus x prime sine phi, okay, plus f. And this equals 0. Okay, so we are going to actually, so what are we doing? By going into xy prime land, now we are going to get uh, a new coefficients of not x anymore, but we are going to get a new coefficient of x prime squared. We call it a prime. We're going to get a new coefficient of x prime y prime, which should be b prime, right? And we're going to get a new coefficient of y prime squared, which is c prime, and same for d, e, and f. And we want it to be where this b prime will essentially, we want b prime to be 0 because that will kill off the x prime, y prime term, which we don't want. Okay, so the way this would work is we would have to expand all of this out, right? We would have to expand all of this out. So I'm going to pause the video recording, write out the expansion. So it will, so the other video will be maybe you all will go bananas this video, and you will just see the final result. Okay, but it's there for you. Okay, so I'm going to pause this and do this work. Okay, so let's see what we get from here. So I've expanded the first these guys out, a minus b squared, a squared minus 2ab plus b squared, multiplied these guys out and expanded this out. I didn't bother with these because there is no xy terms, x prime, y prime terms in this. Okay, so let's now only peel off all the x prime, oopsie, you've got to be careful, I forgot, it's x prime, y prime everywhere, right? Let's pull those out. So what is the coefficient with, or what is being multiplied with x prime, y prime here? It's minus 2a, don't forget this a is being distributed, cosine phi, sine phi. Okay, we have another x prime, y prime term here. What's the coefficient of it? It's plus b cosine square phi. We have another x prime, y prime term here. That is minus b, again this b is distributed, x prime, y prime, sine squared phi. And the last one here, we have an x prime, y prime. The coefficient of that is plus 2 c, 2c, x prime, y. Oh, I should just write the coefficients of everything, sorry. So getting back to this from the first guy, we wrote it's minus 2a cosine phi sine phi. From the second one, it's b cosine square phi. From the third one, it's just b sine square phi. So no need to this. So it's minus b sine square phi. And from the last one, we have plus 2c cosine phi sine phi. Okay, let's write it a little better here. Let's see. Here we have 2 cosine phi sine phi. We know that is, leaving the negative out, that is sine 2 phi, the double angle for sine, right? And here, if I factor out the b, we have inside cosine square phi minus sine square phi, which if you remember, that is the cosine double angle formula, so cosine 2 phi plus 2c. Now 2, again, again, we have the 2 sine theta, sine phi cosine phi, that is sine 2 phi. Okay. And this, we want, these are all the coefficients of x prime, y prime. And I want the coefficients of x prime, y prime, right, to be 0. So essentially, this is all my b prime. I want this to be 0. This looks, what is going on here? Let's add the a sine 2 phi to the other side. So we have b cosine 2 phi plus, yeah, let's just keep the b alone on this side because you want to get, let's give b cosine 2 phi equals a sine 2 phi minus c sine 2 phi. I just took both of these to the other side, right? Okay. All right. Now, I can divide through by sine 2 phi. I can divide through by sine 2 phi because I know, okay, let me repeat this. This is b cosine 2 phi equals, if I factor out the sine 2 phi, and we have left hand side is a minus c. Now I can divide through by sine 2 phi because sine 2 phi cannot be 0. Okay, because my claim is sine of 2 phi, I know it cannot be 0. Now, how do I know it cannot be 0? Because if it were 0, we know b is not allowed to, b is not 0 because that's the b from the original form here. This b is not 0. That's our whole problem. That's why we have an xy term. So that means cosine 2 phi must be 0. So if we are saying if sine of 2 phi is 0, then cosine of 2 phi must be also 0. But there is no angle when sine and cosine are 0 for the same angle, right? We know they are staggered. So it's perfectly fine to divide by sine 2 phi. And cosine divided by sine is tan, cotangent, right? Uh, and let's divide the b. So on the other side, so we get cotangent of 2 phi equals a minus c over b. This is pure magic, okay? If we rotate the axes by phi, right? So how much should we rotate? What should be this angle we should rotate by? We should rotate by an angle such that cotangent of this angle of 2 times this angle is a minus c over b. Okay. Now, how do I know there is always such an angle? And it's an actually even the amazing thing. It's an acute angle. It's an angle just between 0 degrees and 90 degrees. Because here is the idea: if phi is between 0 degrees and 90 degrees, then 2 phi is between 0 degrees and 180 degrees, right? And we know the graph of cotangent, if you remember, is like this, is pi over 2, right? So between 0 degrees and 180 degrees, we cover everything. We cover all possible. So we know that if there is an acute angle, there is an angle to theta for which we will get any number, okay? So again, bottom line, what is the big idea here or the thing that we take away from this? If we have something in the form ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0, we want to sketch the graph of this function. What we are going to do is first find what is the angle such that cotangent of this 2 times this angle is a minus c over b. That's the angle we'll pick. Picking this angle, we will replace all the x's and y's with x prime cosine phi. Now that's the angle we picked here, right? Minus. So using our equation for what is x equal to x prime cosine phi minus y prime sine phi, right? And replacing all these guys with same for the same angle, and you will see nicely the graph. So let me do a quick, it's 41 minutes, but hey, you can hopefully, this is there for those who miss, but that shouldn't exceed class time. So I think I'll, um, I'll, let me just quickly, I've come all this way, let me just do it. So let's do one quick example. Just do this, xy equals 1. Let's graph this guy. We can't, this is actually the graph of y is equal to 1 over x, kind of, it looks like that, remember? This is a hyperbola, but you can see the axes are not, uh, the axes of symmetry are not vertical and horizontal. So let's sketch this graph. Xy is equal to 1. So a is 0, right? Because it's ax squared. C is 0 because cy squared. And b is 1. Okay, that's b xy, coefficient of xy. So we know cot 2 phi is equal to a minus c over b. So that is 0 minus 0, which is 0 over 1, which is 0. Now, what is the angle whose cotangent is 0? So 2 phi must equal pi over 2, or phi has to be pi over 4, or 45 degrees. Okay, so now all we have to do is replace x with x prime cosine phi minus y prime sine phi, and the y is x prime, the y is, make sure you look it up always, the y is y prime cosine phi plus x prime sine phi, and again, you can go back all the way here and see it's right here. We'll bring it over here just to make sure we did do it right. Right? The x is x prime cosine phi minus y prime sine phi, and the y equals y prime cosine phi plus x prime sine phi, and this equals 1. But now our phi is, it's not phi, it's, we know the angle for it is 45 degrees. Right? 45 degrees, 45 degrees, 45 degrees. Okay, we know what is cosine of 45 degrees. That's root 2 over 2 x prime. That's root 2 over 2 y prime times root 2 over 2 x prime. I'm just writing this first for a reason. Plus root 2 over 2 y prime equals 1. This is nicely in the form a minus b times a plus b. That is a squared. That'll turn out to be a squared minus b squared. So root 2 squared is 2, 2 squared is 4, 2 over 4 is a half, y prime squared equals 1. Look at this. This is our good old hyperbola, right? X prime squared over 2 minus y prime squared over 2 equals 1, where our a is square root of 2 B is also square root of 2. So we can actually just sketch this right away. So let's see, this is how we would do this. Is we have rotated, and I'm going to just put it in a different color. Let's see. Yeah, our new 45 degrees, right? Same for the other side. Kind of accurate enough, I hope. So this was our x and y. Now we have our x prime, y prime, our new angle. Now all we care about are new ones, okay? So kind of in some ways you can kind of just disregard the other one. Disregard the other one, okay? And now you turn your head a bit and it's not okay, a right angle it should have been. Actually, I shouldn't have removed this because you'll see a reason. Okay, so what is our A? Our A is square, our center is 0, 0, right? The center is still, the center is the origin. Right? The A is root 2. A is square root of 2. So mark the A's on both of them. It's on the x-axis, right? The A is a root 2 and negative root 2. Okay, the B's are also root 2 and negative root 2. And we connect them, make our box. No, I made the, so you got to keep your head turned. It's only on the X and Y. And, okay. Okay. And we have our asymptotes here then, going through the box, right? We have our two asymptotes, which is actually your original X and Y axes. And we have the graph. The A is going towards this asymptote, okay? And we'll be doing more of this. Okay, sorry for this long video.